Okay, so here's number one. Just have a while loop over here, and then counts the iterations, and then I have that displayed to this indicator, which isn't necessary, but that was just to help see what's going on. Then it checks if the iteration is greater than 10. If it is, the select function here sends a true signal to the LED, which lights up. Um, yeah, and then there's a 500 second or 500 millisecond delay up here, and a stop button. So if I were to run that, we can see it's not lit up until it gets to 11 because it's greater than 10. Yep. And then it stays lit, and it'll stay lit for the rest of time until I hit stop, and then it stops. So yeah, that's that one. Number two. Oh yeah, so this one, number two, wanted a sine wave, just a single sine wave. So the way I have that here is I have the iterations, and then again, just displaying the iterations to help keep track of stuff. And then I check when that's equal to 1,000, and then when it is, it stops. And then up here, I divide the iterations by 1,000, and then multiply by 2 pi. And that's this whole section here just determines how much of the sine wave we see, the wavelength, essentially. And then pass that number into the sine function, and then the waveform. And I put a 5 millisecond delay, just so it's a little easier to see. But let that run. It'll do 1,000 iterations, and then stop. You can see it's a single sine wave. It starts at 0 and stops at 0. So that's good. Number four. Yeah, so this one is literally just a math problem. So first thing I do is take the integer, or the iteration, and then multiply by 2, add 1, and this is the function for an odd number. So basically everything after this is all the odd integers. So then it sends it to two places, well, three places, the solution to, but these two places that matter. Divide by 3, check the remainder. If it's equal to 0, then sends a true signal to this end function over here. Otherwise, that's false. And then also, the odd integers are sent up here, cubed, raised to the power of 3. And then that's checked to see if they're greater than 4,000. And if that's true as well, then it goes to the end function. So if both are true, it stops. And because it's a while loop, it iterates upwards, so starting at 0 and going up. So the first number that satisfies both of these requirements here will be the lowest possible number. That's what the question wants. So we can check that. And yep, gives 21, which I checked is right. The remainder is 0, so that's good. And then cubed just over 9,000. So yeah, we're good there. And then number 5 was the metronome one. So this one is basically, it wants a user-controlled metronome. So I should be able to put in the BPM here and determine how fast the LED lights on and then off. So getting it to flash on and then off is pretty simple, just using the iterations down here, and then just divide by 2 and check the remainder. So again, because it counts upwards from 0, 0 divided by 2, remainder 0. Then 1 divided by 2, remainder's not 0, so it'll go off again because of the select function. Have it true when it's equal to 0, false when it's not. So it's just even numbers on, odd numbers off. Getting the time right was a little bit more difficult, but not too bad. Takes your input here, divide by 60, and then that converts it to BPS, beats per second, which isn't entirely necessary. You can do this all in one step, but whatever. And then I do 1,000 divided by that in order to determine the delay, essentially how much this wait function actually waits in between flashes. So if I were to put 60, right, we should get 1 flash per second. And that's correct. And then also stop button, which works. If I were to do 120 beats per minute, it should be 2 flashes a second. And we can see up here, beats per second is 2. Delay is half a second, which checks out. So yeah, we do something stupidly fast like 200. Really flashy. You get 300 millisecond delay and 3.3 beats per second. So yeah, that works. And also, I could go slower if I wanted. I mean, you get it. 15. So that's yeah, we get 1 beat every 4 seconds here. And that's, yeah, 60 over 15. So, yep. Okay. So, oh, I should have used the actual stop button. Oh. Number 6. This one we have even LED and odd LED and a stop button. So iterations here on the while loop. Divide by 2, check the remainder just like last time. So this basically splits off into even numbers and odd numbers. So if, say it does divide by 2, remainder is equal to 0, then each of these select functions will get a true value. But because I've ordered these backwards, if it's true, then this one passes true through this LED. It lights up. If this one's true, it passes false through the LED. It doesn't light up. And also there's a half-second delay. And that's pretty much it on this one. So, yep. And we can see every half second these swap up here. The iteration show us 18, 20. So those two right here, and then odd numbers down here. And of course the stop button works as well. So yeah. And 7. It's actually this should be good because my laptop fan is going nuts right now. So because I have all of them open at the same time. Let me close them to make this a bit more reasonable. Because this is the one about CPU throttling or whatever. So this was the loop we made in class. So you just run that and it's just a sine wave. So we're supposed to see while it's running at 100 millisecond delay what the CPU looks like. And yeah, that's not great, but it's because I had a ton of all the lab views open at once. So we're at like 16, 15. Okay. And then check it at, I think was it 1 millisecond? And that obviously goes a lot faster and uses quite a bit more for the CPU. We're up to 30-ish now. And the fan's back on. It's so loud. And then also it says to just delete this. So if I were to take that out completely, this would just go as fast as possible. And yep, we're up even higher now. So although not that much higher, but because the difference between 1 millisecond and nothing is not that much, but yeah, a little bit higher. So yeah, that makes sense. All right, and then finally number 8. So this one generates a random number here between 0 and 1, not including 1, and then multiply by 10, and then round up towards infinity is what this one's called. And that essentially just makes this whole thing here a random number generator between 1 and 10. So that then I display that random number here just for convenience sake, and then check if it's equal to 5. And when it is, function stops. I put a 700 millisecond delay up here just because, you know, it's too fast without it. And then the loops, the iterations down here, I check when it hits 5 it stops, and so whatever iteration is displayed here is, you know, how many it took to get to 5. So if I play that, it will go until the round number here hits 5, and then it'll stop, and we'll see how many iterations that took. It also wanted, oh, there we go, 14. So it also asked about how, what I thought the average amount of iterations it would take would be. And since it can generate 1 through 10, figured it would be, you know, 1/10 of the time, 10 iterations average. And sure enough, I counted earlier, I did 20, and then averaged them all together, and I got 10.85. So, yeah, mine was a little bit higher, but on average, it should take about 10 iterations to get 5. Yeah, that's it.